Precalculus 3.1, Day 1. We're going to be graphing and evaluating exponential functions and using the one-to-one property to evaluate some equations. So first of all, just the definition of an exponential function is right here. The exponential function f with base of a is noted f of x is a to the x. So notice the variable x is in the exponent position. And in this case, where a is greater than 0 and a cannot be 1, and x is any real number. So those are some of the details of what needs to happen. You've graphed some of these in Algebra 1, probably started, and then more in Algebra 2. And so let's just go ahead and kind of jump into this. And example 1, use a calculator to evaluate each function at the indicated value of x. And I want you to go ahead and round to 3 decimal places. If you move on to AP Calculus, that is what they round all approximations to, unless otherwise specified, is to 3 decimal places. So in part A, we just want f of pi, which is 8 to the pi, and then this is a calculator problem. In part B, you want f of 1/2, so you're going to have 8 to a negative 1/2, and in part C, you need f of negative 2.5, so it's 0.8 raised to the negative 2.5. And then this is an approximation when you round to 3 decimal places, and I just went to Desmos, and in Desmos there is a scientific calculator. So if I add a new one and go to Desmos, and then if you scroll up at the bottom, products, graphing calculator, scientific calculator. So you can go to the scientific calculator, and then you are evaluating 8, and then you hit a to the b, and there is the pi symbol, and you hit enter. To 3 decimals, 687.291, and then you need 8, and then hit the a to the b, and subtraction for negating 1 divided by 2, and you go 0.354. You need to do correct rounding on those, and then 0.8, a to the b, raise that, and to the negative 2.5. So 1.747. And so those are evaluated. So go back and put those into 3 decimal places, 687.291. 8 to the negative 1/2, 0.35. You need to do correct rounding on that. And same thing with part C, 1.747. So those are your answers. Now, to graph these, I want to see a table of values. And we're going to go and we've got 3 to the x. When that base is greater than 1, this is going to be exponential growth. And what I like to see for part A is a table of values for x negative 2 to 2. And so you get for 3 to the x, here's your x, you have 3 to the negative second, which is, if you drop that to the denominator, you change the sign on the exponent to being positive, and that's a 1/9. So at negative 2, you're at 1/9, which is very close to the x-axis. And then at negative 1, you have 3 to the negative first, which you can write as 1 over 3 to the first, or 1/3. So at negative 1, we're up a little higher. And then you get 3 to the 0th, and something to the 0th is always 1. And you get 3 to the first, which is 3, and 3 squared, which is 9. So you've got to the right 1, you are up 3. And then to the right 2, you're up at 9. And so it has this x-axis as a horizontal asymptote. put arrows on that to indicate it's going to go. And there we have sketched 3 to the x. And so some things, you need to know is when it's increasing as you go left to right, it's exponential growth. And it has a horizontal asymptote, at least as you go to the left, of y equals 0. So as x goes to negative infinity, y is going to 0. 0, at least to the left-hand side, there's a horizontal asymptote. Now, if I go ahead and graph part B, g of x is 9 to the x. Again, table of values, oops. And we have x, and we have 9 to the x, negative 2, negative 1, 0, 1, and 2. You're going to have 9 to the negative second, which is 1 over 81, which, oh boy, that's even closer to the x-axis than 3 to the negative second. And then 9 to the negative first, which is going to be a 1/9. And 9 to the 0th is 1. And 9 to the first is 9. And 9 squared is 81. And so when you go to plot this, when that base of 9 is higher, it actually is below to the left. At 0, 1, they agree. So it's kind of going in between there. It's kind of hard to show that. And then to the right 1, I'm up at 9. To the right, because that base is steeper, it's actually going to go up more quickly. So to the right of the y-axis, it goes up faster than a base of 3. To the left of the y-axis, it gets closer to the x-axis more quickly because you have a larger number of 2 powers in the denominator. And so they kind of switch which function's on top versus which one's on the bottom as you change from the left of the y-axis to the right of the y-axis. But they both are exponential growth and have a horizontal asymptote of y equals 0. Now, if we change this up and in the same coordinate plane sketch the graph of these other functions, so in part A, we have x, and we have 3 to a negative x. Then we have negative 2, negative 1, 0, 1, and 2. But now I get 3 to the opposite of a negative 2, which is 3 squared. Excuse me, and this is 9. And if I have 3 to the opposite of a negative 1, I have 3 to the first, which is 3. And then I get 3 to the 0th, which is 1. Then 3 to the negative 1, which is going to be 1 over 3, or 1/3, and 3 to the negative second, which is 1 over 3 squared, or 1/9. So these are actually changing. This is going to be exponential decay, because as you go from left to right, it's going to decrease instead of increase. And so at that's a negative 2, I'm up at 9. And negative 1, I'm at 3, 0, I'm at 1, and then I'm at the 1/3, and then the 1/9. And so this is exponential decay. Now it has a horizontal asymptote as we go to the right. Of y equals 0. As x goes to positive infinity, y is going to 0. So there's that graph. And what is actually you can think of this as is f of x being 3 to the negative x can be 3 to the negative 1 to the x. Because powers are powers, you multiply, so I can write that as 3 to the negative 1 to the x. If I went backwards, I get 3 to the negative x. And 3 to the negative 1 is 1/3, so this is actually 1/3 to the x. And when that base is between 0 and 1, and that exponent's just a positive x, you're going to expect exponential decay, that it's going to decrease as we go from left to right. Then if we switch and we do to the 1/9, part B, but we have 9 to the negative x. We have negative 2, negative 1, 0, 1, and 2. Again, just the exact values here. You get 9 to the opposite of -2, which is 9 squared, or 81. We have 9 to the opposite of -1, which is 9 to the first, which is 9. You get 9 to the 0th, which is 1. And you get 9 to a -1, which is a 1/9. And you have a 9 to a -2nd, which is 1 over 9 squared, or 81. So again, at -1, you're at 9. At -2, you're way up at 81. At 0, you're at 1. They share that point. But then as we go to the right, at 1, you're at 1/9, which is lower. And at 2, you're at 181. So it goes to the x-axis much more quickly than the base of 1/3 did. So on the left side, the base of 9 is going to go faster. And so it looks like this. So they kind of switch which one's on top and which one's below across the x-axis or the y-axis. So, but both of them share a one-sided horizontal asymptote, and they are both exponential decays. So there's just some summaries between y equals a to the x and y equals a to the x. Now, this is when a is greater than 1. And so this y equaling a to the x, a greater than 1, is going to be exponential growth. Versus when a is greater than 1, this is going to be exponential decay. So the domain on all of these, -infinity to infinity, range 0 to infinity. Oh, and I need to change this. This needs to switch. I always put the lower to the left, -infinity to infinity. Didn't get that. It was an error last year and I didn't get a change, sorry. All right, so -infinity to infinity. And range 0 to infinity, y is greater than 0. It's not 0, but it's greater. This is the basic one. Y-intercept is 0, 1. And when a is greater than 1 and y equals a to the x, this is an increasing function. So you have the x-axis as a horizontal asymptote as the y values will go to 0. So as x goes to -infinity, y is going to 0. That a to the x is going to 0. And it's a continuous function. There's no places like where we had rational functions, where we had holes or vertical asymptote. That's not happening here. And then in the case where we have a to the -x, but a is greater than 1, it's a decreasing, it's exponential decay, and the domain still -infinity to infinity, range is 0. That I didn't catch that last year. Yeah, that's not right. The range is 0 to infinity, and y-intercept is 1, and this is a decreasing. And the y value will go to 0 as x goes to infinity. As x goes to infinity, the y is going to go to 0. And it's a continuous function. So notice that the graph of an exponential function is always increasing or always decreasing. So you're going to need to graph them and include some tables of values and plot those accurately. All right, so now we have this one-to-one property. And when the directions are solved using the one-to-one property, you need to do them the way that we're doing these. What you're going to get is you want to strive for common bases. So we're going to rewrite with common bases and then equate the exponents. And then equate the exponents. So these are specifically designed so that you can do them this way. So in part A, I have 16, and I should know that 16 is 2 to the 4th. And on the right side, I have a base of 2. So right there, I've rearranged 16 to have a common base. And if the only way that those are going to be equal are if their exponents are equal. So they will be equal if 4 equals x plus 2. Subtract 2, and x is equal to 2. In part B, what you need to recognize, I want to get a common base, and 81 is 9 times 9, and those break down into 3 times 3 times 3 times 3. So in other words, 81 is 3 to the 4th. So now that's starting to get these to be somewhat similar. At least they have a 3 in them. And then if I flip this fraction, the 3, I can write it as 1/3 to the negative 4th. So 3 can be written as 1/3 to the negative 1. So 3 to the 4th would be 1/3 to the negative 1 to the 4th, which powers of powers you multiply, you get 1/3 to the negative 4. Now, and so now that we have like bases, we can equate exponents. So that means x must be a negative 4. Now, an alternate way to do that one, which you might prefer, is I can rewrite 1/3 as 3 to the negative 1, which then becomes 3 to the negative x. And I can write 81 as that 3 to the 4th. And now equate exponents, and a negative x equals 4, or x is a negative 4. So there's an alternate way to see that. Either one is just fine. But the key is to rewrite with common bases. And then after you get the common bases, you can just equate the exponents and solve from there. All right, so in example 5, you're going to describe the transformations of a graph, and this is supposed to be 7 to the x. And so if you remember some of your transformations, if you have f of x and you replace it with, say, f of x plus a, that function is going to be moving to the left a units or the right a units, depending on the sign of a. If a is positive, then it's going to be moving to the left a units. Those kinds of things. And so if I have f of x is a to the x, and then I have f of x minus 3, that means I'm going to take a to the x minus 3. That's going to mean that I'm moving that function to the right 3 units. And so that's what we're having here. We have our original function f of x is 7 to the x, and you see 7 to the x minus 3. You have transformed the function f of x to the right 3 units. And then when you have f of x and you negate it, that is a reflection in the x-axis. So our original function is 7 to the x, and you are negating that entire function. So this is a reflection in the x-axis. And when you have a function for part C, f of x, and you replace it, the x with the opposite of x in that equation, that is a reflection in the y-axis. So this particular transformation has two things happening. It has where you have the reflection in the y-axis, and then if you have f of x, but to that f of x, you add some number or subtract it, that is moving the function up or down. So in part C, you have both a reflection in the y-axis and you're going to go up 3 units. So, by the way, there are some orders to how you have to do transformations. And we call it our high 15. Instead of a high 5, it's a high 15. And we spell it HYXV. Sorry. I'm just, Rick, I'm recording. Sorry about that. And so anyway, so the order of transformations, high 15, is for H, you have do horizontal, followed by reflections in the y-axis, and then reflections in the x-axis, and then followed by vertical movements up or down. And basically, if you do it in that order, that's going to be good, but especially if both horizontal and over the y happens, you must do horizontal first and then over the y. Do it in this order. And the other super important ones, if both over the x and vertical movements are involved, you need to go over the x first, and then you can move it vertically. So if you have f of x is 3 to the x plus 2 and plus 1, this is left 2 and up 1. And so that would be a horizontal and a vertical. They don't have either of the two above, so you could do them in any order, but I would just go left 2 and then up 1, and you'll be safe. But anyway, so there is an order to transformations to be aware of. If you have both horizontal and over the y, you've got to do horizontal first. If you have both over the x and vertical, you must do over the x first. If you have something like this, it doesn't really matter because you don't have those paired up with those special ones. But there you go.